Okay, so today we're going to talk about the volume of spheres. So if you look on your volume formula chart, you see we have three different formulas there: prism or cylinder, and in 8th grade we are doing cylinders. Pyramid or cone, again 8th grade cone, and you remember that's 1/3, that's how it's different. So now we have sphere, and sphere has this, I don't want to really say crazy, but kind of formula with a lot of numbers. Okay, so here's the good thing about a sphere. They only give you one number on a sphere. You just have to figure out, is that a diameter? Oops, I'm running out of room to write. Diameter, or is it a radius? Okay, so remember, diameter goes all the way across, radius goes halfway across. And since this is like solid line, I'm not really sure what to make of this. Is it a diameter? Is it a radius? Let me erase my writing and see if I could kind of see what they're pointing at here. I think since it's kind of written in the middle of the line, I think I'm going to consider this 10.6, this entire length, which would make it a diameter. That's what I'm going to say. Oh my goodness, I can't write my 6 there. There you go. Which makes the radius 10.6 divided by 2. So my radius is 5.3. Now that's all you really need to know, because 4/3, here's my formula. 4/3 is just 4/3. You can put that into your calculator, control divide, 4 in the numerator, 3 in the denominator. Then you have pi, which you can use the pi button. Then you have r to the 3rd power. So times, and 5.3. So I'm going to use parentheses, to the 3rd power. So to get that 3, there's a couple different ways you can do it, but what I do is push, oh my goodness, where's the calculator? You need to push the button that looks like a little arrow. It is next to the x squared key. So on your calculator, you have these two keys. This one does this one does this. This will give you a power. So you push that button, you'll get the little box. You can put a 3 into it. Okay, so that's all you have to do. But why? Don't you want to know why? Well, I'm going to tell you why. To your notes. Write this down. Okay, so V equals, we're going to write the formula right from your chart. 4/3 pi r cubed, or to the 3rd power. We're going to substitute. Well, 4/3 is 4/3. Pi is pi. I'm sorry, the radius is 5.3 to the 3rd power. And then we're going to get our calculator. And hold on a second until I grab one. Okay, and when we put all that in there, we are going to get 623.298. So you can round that to 623.3, and this is inches cubed. All right, so we haven't been filling in this side over here. Okay, so let's do that now, because it's going to be the same for all. All that means is that in terms of pi, we're leaving, whoops, I thought I had a pen. We're leaving pi alone. Okay, so in this case, this is all going to look the same. 4/3 pi r cubed, 4/3 pi 5.3 cubed. But now we're going to do all the math stuff and just write the pi symbol down, because that's in terms of pi. So hang on, I do need a calculator. Okay, so I put that in the calculator and I get 198.503, but you have to write pi inches cubed. Okay, so look at the difference. This, in terms of pi, you just leave pi in there. Okay, this has no pi in it because you've multiplied by pi. Okay, we used to see a lot of this on your test, on the STAR test. Not so much anymore. The only place I've seen that is when they ask you to choose the correct formula to find the volume. And we'll look at one of those or a couple of those before testing for sure. Okay, all right, so remember, use a radius, not a diameter. And make sure you are doing the third power, not squared. And don't forget this 4/3 times pi. Like a lot of people forget that this means multiply. So use a multiplication sign. Alrighty, then glue that into your journal and you are ready to move on to the whatever's next on your pathway. I can't remember if it's going to be the reflection or the Google form practice. Alrighty. So if I think about our volume formulas, right? Volume is like area of a base times the height, right? Well, sphere doesn't really have a base. And then we talked about the cylinder having a rectangular base. And we talked about the cone, being 1/3 of that because it takes 3 cones to fill up a cylinder. Well, if I poured water or popcorn from a cone into the sphere that has the same diameter, it would take 2. So 2 cones would fill up a sphere. 2 cones fill a sphere, again, having the same diameter. So let's see if we can figure out where this crazy formula comes from. 2 cones, well, this is the formula for a cone. So 2 times those will give me the volume of the sphere, because 2 cones fill a sphere. So let's think about this. So I have 2 times 1/3 is 2/3. Then I have this. Here's the part that's bothering me. A sphere has a height. I know what a radius is. That's easy. Same thing as the cone, the halfway across from the center of the sphere to the edge. But the height, if I think about a sphere, don't judge my circle, and I think about how high it is, the height of it, I'm like, oh, look, I went all the way across the circle through the middle. That means the height is the diameter. Well, how do I find the diameter? Since I have an r here, I really want to do that in terms of r. Our diameter is equal to 2 radiuses, or 2 radii. So now instead of height, I'm going to write 2r. Because the height is a diameter, and the diameter is twice the radius. Well, now I'm just going to clean it up a little bit. So 2/3 times 2 gives me 4/3. 2/3 plus 2/3. Pi is pi. And now I have 2 r's here and 1 here. So r to the third. And that's where your formula comes from. Do you need to know that? No. But it's kind of nice to know before you just write some random formula down and start plugging numbers in. Like there's a reason why it is what it is. Okay? So the biggest mistake people make with this formula, they use a diameter instead of a radius. And they forget that that's a 3, not a 2. Okay, so make sure you don't make those mistakes. All right, let's